Do you know how to measure the thickness of this sheet of paper using a ruler? Do you know how to measure the diameter of this thin wire, or how to measure the volume of a stone with an irregular shape? Now with Mr. Mohammed Sultan, we are going to learn how to measure the length, the volume, and the time.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello dear students. Today inshallah in physics for IGCSE we'll talk about topic 1 and especially this measurement techniques. Let's start. When we talk about measurements, we have here measuring length, measuring volume, and measuring time. You know that the best description for any quantity is to measure it. We'll start with measuring length. Here in this lesson, we'll talk only about measuring length. And when we measure the length, we have only one tool here in this syllabus, which is the ruler. So the ruler here is the measuring tool for the length in this lesson. We'll not talk about any other measuring tool. Okay, but we have to pay attention to some things. Like what? If I have here these two rulers, I have here ruler A and ruler B. In your opinion, which one is better to be used for measurement? Ruler A or ruler B? Of course, yes. Ruler B is the best here to be used. It is much better than ruler A. Ruler A has only centimeters. And in ruler B, we have millimeters. We have smaller units. We have smaller grades. So the smaller the grades are, the more accurate our results or our measurements. Okay, so this is very, very important to pay attention to. Okay, this is very easy, but can we make it more difficult? Yes, of course. What if I have a curved thing like this or a curved rod like this, and I want to measure its length? How to measure the length of this rod? Using this ruler. Using this ruler in this way, I cannot use it at all here, but we have a solution here. We have to think out of the box. Look here. This one here is curved, and this ruler cannot be curved. But we can get another thing like a thread. We can use it here and lay it along the curved rod. We mark this point, and after that, we lay it here, okay, beside the ruler, and from this we can get the length of this one. I think it is easy. Again, if we have a curved bar, a curved rod, a curved thing, we cannot straighten it. By using a piece of thread, it is very easy to measure the length of this one. Okay. What if we want to measure the diameter of this wire or this wire using the same ruler? How? Look here. We can simply wrap it around a pencil, around anything, and don't leave spaces here. Don't leave spaces. Just wrap it around the pencil, and we get the ruler. This ruler can be used here to measure this distance or this length. And we get this length from this point to this point, a total length here. And we divide it by the number of turns. Now we can get the diameter of each wire here. Simple, very simple. So if we have a small length, we can get it, or we can measure it using the same ruler here, but we have to think how to get it. For example, this one, we make many turns of this thin wire. Now we have a considerable length. We can measure it using this ruler. Another challenge, this sheet. How can we measure the thickness of this sheet of paper? To measure the thickness of this sheet of paper, I think is difficult. Yes, of course, using the ruler, it is very difficult to get the thickness of this sheet of paper. Okay, how to measure this? Remember this one? I have a thin wire, so I made many turns. The same thing here. I have only one sheet of paper. And can we measure its thickness? Of course, if we have many of it. If we have stack of paper like this, for example here, if it is about 200 sheets of paper, okay, or more, whatever, okay, we can get this stack of paper and we can get the ruler, measure from this point to this point, and from this one, we can get the total height over the number of sheets, and from this, we can get the thickness of each sheet. So we can use the ruler here to measure a length, to measure a very thin or a very thin thickness or a very small length. By making a lot of these, by making a big number of these small lengths, and after that we can get the small length. I think it is easy, as we said in the beginning. This lesson is the easiest one, and it is mostly used in paper 6. Okay, now to measure the volume. How to measure the volume? Measuring the volume, we have here two techniques. We have regular shapes, like these ones. We have cube, we have a sphere, we have cuboid. So from these, if we know the length, we can measure the length here, the length here, the length here. If we know the radius here, if we know the lengths here, we can get the measure the volume by calculating. So we use the formula here. What if we have a liquid? What if we have an irregular shaped solid? Not regular like this. What if we have this or this? How can we measure the volume of these irregular shaped solids or the liquid? How can we measure the volume of these? We have here a measuring tool called the measuring cylinder. The measuring cylinder is used to measure the volume of a liquid, like water, and it is used to measure the volume of an irregular solid which can be immersed in this liquid. Okay, so the measuring cylinder, we use it to measure the volume of the liquid or like water, and we can use it to measure the volume of an irregular shaped solid which can be immersed in the water. But how can we use this one? Please pay attention to these points because we have questions, many questions coming in paper 6 talking about the precautions when we deal with these measuring cylinders. The first thing, if we are measuring the volume using this measuring cylinder, and we have these positions, which position is the correct one? I think, yes, all of you will say that, yes, this one. We can say that we keep it vertical, or we put it on a horizontal base like this one, and this the cylinder is placed on this horizontal one. Okay, so if we put the cylinder on horizontal base, it stands vertically. So this is the first precaution we have to take when we use the cylinder for measuring the volume. What else? Aha, when we want to measure the volume of the liquid, what to do here is to look at the meniscus. What is the meniscus? The meniscus is the curved surface of the liquid. The curved surface of the liquid. This is called the meniscus. Okay, how to know the volume here? To know the volume here by looking at the bottom of the meniscus. This is the second precaution. What is the third precaution here? How to look at this one? Do we look at it like this, or like this? Aha! Here we have 3 or more positions to look at this bottom of the meniscus. Yes, of course, B is the correct one. I know all of you know this. That's why I said this is an easy lesson. To look at the bottom of the meniscus, we look at it perpendicularly. We look at it perpendicular. Why? Because if we look at it from A or B, we will have an error. Okay, parallax. So from this one, again, we have 3 precautions to pay attention to when we are using these ones, to look at it, to put it vertically or on an on a horizontal base. After that, to look at the bottom of the meniscus, and the third one to look perpendicularly at the grade. And this one is used here not only for the cylinder. This is also used when we look at the ruler. When we look at the ruler, we have to look at the grade perpendicularly, not like this. So in any device which has grades like this, which has a pointer, okay, we look at it perpendicularly, okay, to get an accurate measurement. Look here. Who can tell me the measurement or the volume of the liquid here? For example, this liquid is n cubic centimeter. Okay, look at this one. What is the volume of this liquid? And before we answer this, I said here cubic centimeter. Okay, this is from me, from my side. Just look at this. This means this is 1 cubic centimeter. This is 0.2 cubic centimeter. This is 0.3 cubic centimeter. So what is the volume here? To get the volume here, we have to look at the 2 numbers here. This is 0.3 and 0.2. Okay, and how many grades or how many spaces are here? How to get this one? Please look at this. Look at this point. We get the difference between the 2 grades here, this one and this one, the 2 major ones, and divide this by the number of spaces here. We have here 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 0.01. So each space here is equal to 0.01. This is 0.2, 0.2 plus 0.01 equals 0.21. So this one will be 0.21, 0.22, 0.23, and so on. Okay, so this volume here, okay, is between 0.22 and 0.23. So we can say that it is 0.2 to 5 or cubic centimeters. What about if we have a solid and we want to get its volume? This an irregular solid here, and we want to get its volume. Look here. To get the volume of an irregular solid, it is very simple. We just bring a cylinder like this and put a suitable amount of liquid, such as water here, okay, and get the measure or get the volume of the water before adding this solid. For example, it is here, it is 4 cubic centimeters. Good. Okay, so volume 1 equals 4 cubic centimeters. What about after adding this one? After adding this or after immersing this solid in water, the water is displaced up. You have here displacement of the liquid or of water. When we put this here, the liquid is displaced up. So we have a new volume here. Volume 2 equals, who can tell me? This is 10, this is 15. So each grade here, we have here 5 spaces and 10, and this is 15. So each space is 1. So this is 10, 11, 12, 13. So volume 2 equals 13 cubic centimeters. Good. How can we get the volume of this solid? Now I think all of you got it. We have the volume of the solid equals V2 after adding this minus V1 equals 13 minus 4. So the volume of the solid equals 9 cubic centimeters. Very simple. So to measure the volume, as we said, we have regular shapes. We use just equations to calculate the volume, calculations. But if we have a liquid or if we have an irregular shaped solid, we use a measuring cylinder like this one. What if we are measuring the time? When we are measuring the time, we use clocks or timers, stopwatches. We have analog ones, and we have digital timers or clocks, stopwatches, whatever. So we have analog clocks and digital timers or clocks. In your opinion, which one is better to be used, the digital or the analog? Of course, the digital one is more accurate because I have here, if we look at this hand, this is the second hand. This is used here to count the seconds. So we calculate the time here to the nearest second. But this is the minute, this is the second, and we have here hundredths of second. So we measure here to the hundredth of second. So this one is more precise because, as we said about the ruler, the smaller the grades, the more precise we have in our calculations. Okay, or in our measurements. This is very simple and very important in the same time. Look at this one. What if we are measuring the short time interval? You remember when we talked about the small length? In the small length, we put these small lengths together and get the total length and divide by the number of, for example, the thickness of the sheet. We divide it by the number of sheets. What about here? Here, if we are calculating the period of the pendulum, the period of the pendulum, what is the period of the pendulum? The period is the time. The time for what? For one oscillation. How to know one oscillation? Look at this. If I have it, this is A, B, C. If this pendulum moves from A to B, from B to C passing by A, and after that from C to A, so that oscillation is the motion taken by this pendulum when it passes by A twice or two successive times in the same direction like this. This is one complete oscillation. The time taken to make this one oscillation is called the period. And if we have a pendulum like this pendulum is moving, and we want to get the period of it. Look at this. The period can be in a time which is smaller than 1 second. Yes, we can get the stopwatch and we can measure the time of it. But look at this. What if we have a very short time like this? Which is better, to measure the time of only one oscillation or to measure the time of a number of oscillations and get the average? Of course, yes. To measure the time of a number of oscillations and after that to get the average by dividing the total time by the number of oscillations. For example, here, if I want to get the time of one oscillation, for example, you know that our response to stop the stopwatch can have a delay of time. We can have an error. But if this error is divided by a big number of oscillations, it will be minimized. So again, we take the number or the time of a big number of oscillations, to divide the error by a big number of oscillations, and in this case, the error is minimized. For example, if I have here this pendulum and I want to get the period of it, we can get the time for example, of 20 oscillations. For example, if this time is 15 seconds. Okay, how to get the period? The period or the average time equals the total time, which is 15 seconds, divided by 20 oscillations. In this case, it will be 0.75 seconds. So from this calculation, we can minimize the error if we are measuring the time. Okay, look here. We studied here time, length, and volume. For example, here for length. What is the unit of length when we are measuring length? You know that we have many units of length. If we are measuring, we can say that it is meter, centimeter, millimeter, yard, okay, mile. But we must here use the SI unit. SI unit comes from the International System of Units, from a French translation of the International System of Units. This SI unit of length is meter. Okay, but sometimes we have a smaller units than meter. So we can have here fractions of meter. And we can have here multiples of meter. Okay, you know that multiples, it's only one thing, which is 1 kilometer, which is a big one, and it equals 1,000 meters. So 2 kilometers, 2,000, 3 kilometers, 3,000, and this. Okay, what about fractions? Fractions are small things. For example, I have decimeter. The decimeter equals 0.1 meter. What about centimeters? The centimeter equals 0.01 meter. Okay, millimeter, we add another 0. So the decimeter is 1 over 10 meter. This one is 1 over 100. This one is 1 over 1,000 meters. What about micrometer? Micrometer has this symbol, micrometer. This is mu, a Greek letter. Micrometer is equal to 1 over 1 million. This means it is 0.02345 meter. So 1 micrometer is equal to 0.501 meter, or 1 out of 1 million of meter. Okay, these are the units or the fractions and the multiples of the meter for measuring the length. Okay, what about the volume? In volume here, for the volume, we have meter cube. Meter cube means meter times meter times meter, because the volume is the space occupied by the object, and the space occupied by the object is 3 dimension. This means we have to get the 3 dimensions. This means length times width times height, for example. Okay, so this is the SI unit. Do we have fractions of this? Of course, we have fractions of this. We have 1 cubic decimeter. Okay, how many cubic decimeters in 1 meter cube, or 1 cubic meter, or how many cubic meters in 1 cubic decimeter? Look at this one. 1 decimeter means 0.1 meter times 0.1 meter times 0.1 meter. This means it is 0.0, okay, 0.1 meter cube. So 1 cubic decimeter is equal to 0.001 cubic meter. What about 1 cubic centimeter? It is equal to 0.01 meter times 0.01 meter times 0.01 meter. So 1 cubic centimeter is equal to 0.00001 meter cube. For the time, I think you know that it is easy to talk about the time. The SI unit of time is second. Okay, and this is the end of our lesson today. Thank you very much. Hope you understood everything of this easy lesson, inshallah. We'll have a practice on this lesson soon. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.